Okay, so we're going to predict the flight time. And to predict the flight time, you're really just trying to see how long it takes until it lands, right? And in order to do this, you really only need to concentrate on the vertical component, right? Vertical component meaning the up-down path of the rocket. So I know it's going on an angle. It's actually when the path of the rocket's kind of like parabolic. It's going to go up, then down, and it's going to hit the ground over here. So it starts here, goes up like a parabola shape, and hits the ground here. But it has a sort of a vertical shape because it's going up and then it's going down. And once it falls down and hits the ground, the time stops. All right. So if you're going to find the flight time, what you're looking for is how long until it hits down on the ground. So what we're going to do is we're going to sort of forget about the curve and we're going to concentrate on just the up and down motion. And from our previous example, our vertical component had a velocity of 6.9 meters per second. Now let's be more specific, it's the initial velocity. So when it first started, it rocketed off at 6.9 meters per second vertically. Alright, so we're going to use that as U. U is 6.9. Okay, acceleration is negative 9.8. And our displacement is actually going to be 0. If you remember what I spoke about earlier, because we've gone up and we're just talking about the vertical component, because we've gone directly up and back down, we're actually 0 meters away from where we started, right? It's not the distance you've traveled, it's the displacement. So we're going to plug these values into our formula. S equals UT, so 6.9 T, okay, plus half times acceleration, which is negative 9.8, times T squared, right? And we're just going to sort of substitute values, so we're going to work things out. Half of negative 9.8 is negative 4.9 T squared, and we're going to use our knowledge of rearranging equations. We're going to add 4.9 T squared, which means we get 4.9 T squared equals 6.9 T, right? Sorry, I should have mentioned we add 4.9 T squared on both sides. So we've got 4.9 T squared equals 6.9 T, and we can actually divide both sides by T, which is going to make your life a lot easier. I don't know why I'm working in red. Anyway, so that becomes 4.9 T equals 6.9, and now we just divide by 4.9 on both sides, and that'll give us T, which is 6.9 divided 4.9, 1.4 if I round it to one decimal place. So 1.4 seconds, right? So that means it's going to take 1.4 seconds to jet off and then land again, which sounds about right because when we faced the rocket directly up, it took 2 seconds, but as soon as you put it on an angle, the flight time shortens. Okay, and that's how it should work. I think that one's done. Oh, we should do a little therefore statement. Therefore, the flight time is 1.4 seconds.